And welcome everybody to the Daily Space Weather. Currently looking at a composite image of the sun here, and tons of stuff to talk about today on the Daily Space Weather. I'm your host, Dan, aka smAsho. We'll be talking about an increased risk of coronal mass ejections. In fact, one is sort of unfolding right now. We'll talk about the solar polar fields and about how there is a geomagnetic storm incoming. Here's a composite view here from the SDO, 3 wavelengths, 211 angstroms, 193 and 171. Large coronal hole in the Earth-facing zone right here. And NOAA's forecasting an early onset of a coronal hole high-speed wind stream. Here's another view in 171 angstroms and colorized magnetogram. We've got one sunspot up here, and we've got a jack-o'-lantern-like sun in effect here with a coronal hole for a mouth and 2 active regions for eyes. Here's just the 193 angstroms view and a more defined view of that coronal hole. It is South Pole oriented. It's creating some changes in the sun's B field as the solar polar field reversal commences in very slow fashion, at least compared to the last cycle. So next we're going to show a diagram of the solar system as we prefer our viewers to be oriented to things like facts. Here's where planets are in the solar system, as well as phase of the moon and so on. ThePlanetsToday.com also has a geocentric view if you're interested in what astrological signs things are in. There's where things will be in a week. We'll have a gibbous waxing as we approach the next full moon, coming right toward the end of March. Here's what's going on above my head. And I'll just advance this as we see some planets rising ahead of the sun here: Saturn, Jupiter, and Mercury. And as Venus is just about to slip around the back of the sun as well, you'll see it rising just ahead of the sun. Regarding the radio flux of the 10.7 centimeter variety, the 2,800 megahertz radio flux, it's currently at 78 solar flux units. Here's the 1-year chart of that. The black line, red line underneath is the sunspot number. You can see how proportional those two stats are. And here's NOAA's forecast for the incoming coronal hole wind stream, expected to show up early tomorrow universal time on March 20th, with approximately 6 hours of a G1 geomagnetic storm. The lowest level, a KP of 5, is what the forecast is. And great view of, again, Venus about to swing around the backside of the closest star. Please leave a comment if you're viewing from a different solar system, galaxy, universe, etc. And we've got some more solar imagery to show you at the end of the video as well. Here's one more view, and we've got some filamentary activity down here, which looks like it's in the process of ejecting. You should actually see that right at the end of the video there. There is a small coronal mass ejection unfolding. No idea what the telemetry is yet because it's not showing up on enough instruments for us to really go in depth into that at this time. We'll have to wait a few hours to update you on that. So that filament did erupt. I believe it is on the process of exiting the corona. And here's one more close-up, one of our close-ups. It's sunspot 2810, and you can see it's remained pretty stable here in 1700 angstroms, rather. Another part of the UV spectrum. So a great close-up there of 2010, sunspot 2010. And we've brought you to the do not pole vault the caldera section. And of course, we like to make light of certain events on the channel, but some of them are pretty serious. And it's a public service message. Do not pole vault the caldera. And if you feel like you're at your breaking point, hold on. Things will eventually improve, I promise. What hasn't improved is the display at volcanostoday.com. The Volcanoes of the Day section is looking a little jacked up. So let's do the list of the currently erupting volcanoes. They consist of Mount Ibu. It's producing a 7,000-foot ash plume. Semeru, 13,000-foot ash plume there. Those are both at Indonesia. Dakono is exploding as well at Halmahera. I have no idea where that is. Please leave us a comment if you know where Halmahera is located. Does it show us a map? Also around Indonesia, so obviously an Indonesian island. Fuego in Guatemala. Most of our North American viewers know where that's located. Is producing a 14,000-foot ash plume as it explodes. Sangay and Revenador in Ecuador also exploding. Both of them. Revenador launching some lava bombs and producing a 15 to 16,000-foot ash plume. Sangay, 20,000-foot ash plume. So that's an uptick in Ecuador. Sabancaya, intermittent emissions from Peru. And Piton de la Fournaise on the Isle of Réunion back on the list. Renewed seismic activity located there on the French island of La Réunion, which is someplace off of the African continent. And we see some lava fountaining having happened there on December 8th, 2020. In any case, folks, don't pole vault the caldera. No matter how bad it seems, things will eventually improve. If you want to tell your friends not to pole vault the caldera, pick up one of our shirts. You can link to all of it at smAsho.com. Also, thanks to our new forum posters and everybody who's signed up for the currently free forums at smAsho.com/forum. I'll get to the answers to your son questions momentarily. Marianne, thanks for commenting there. We've got new posts in the COVIDiots forum as well as the Cosmology forum, just a few days in the thread of the most. So we don't want to search, we want to show you what the store looks like. And there's the Red Bubble shop. Again, you can link to that at smAsho.com. It's the smAsho merch link. So check out our homepage. Next, we'll do earthquakes here as we see a 6 magnitude quake happened in the Mediterranean, just off the north shores of Algeria. There's the location of that. A 6.0 magnitude quake there in a fairly mountainous region, probably not having done a lot of damage. And let's go up the rest of the list here. No major quakes. That was the largest. And some aftershocks centered right on that same area, as you can see over there on the map. Just north of Algeria, a few miles into the Mediterranean. A 4.8 magnitude deep quake struck Indonesia. And that Algerian quake happened at 4:06 Universal Time this morning on the 18th. Extremely shallow quake at Hawaii. That one at 1,000 meters above sea level, directly under Mauna Loa. An altitude of like 3,300 feet or something like that, 3,200 feet below the Mauna Loan caldera. Earth's largest volcano, which has been expanding for an extended period of time, by the way. Guatemala saw a deep quake as well. A couple 5+ magnitude quakes around Kamchatka, on the eastern coast area of Kamchatka, like this 5.2. There's a location of that. And also a deep quake struck Fiji, a 4.3 at 590 kilometers. Actually, in between Fiji and the Kermadec Trench. And if you're a new viewer, the Kermadec Trench is this ocean rift zone right here, where we saw that 8 magnitude trench. It's just south of the Tonga Trench. Leave us a comment if the Kermadec Trench is your favorite trench in the ocean. And I've lost control of my browser. Please bear with me while we resolve these temporary asides. And let's get off of earthquakes and back to solar data. So here's the GOES X-ray flux over the past 3 days. No solar flares at all to speak of. Last B-class flare happened on the 16th. And I think I said the geomagnetic storm is forecasted for tomorrow. It's forecasted for early on Sunday. On Sunday. Early on the 20th. So early on Friday morning, not tomorrow. Just a little correction there. GOES proton flux is flatlined. We don't see any coronal mass ejections. Not yet, although again there is one unfolding. It's sort of in the Earth-facing region, but I highly doubt that it will be Earth-directed. GOES magnetometer over the past 3 days is showing a little higher highs and lower lows. And for you new viewers, the N's and M's, they stand for noon and midnight time. Local time for the GOES 16. Next, looking at some magnetic data. This is from the National Sunspot Observatory. It's from 51 ground-based magnetometers, as well as magnetometers at stereo A and B, which are at Lagrange point 5 and Lagrange point 4. Those little dots right there, that's stereo A and B. And this shows us the polarity of the current sheet, and the polarity of the current sheet shows us other features. And by the way, this is not how I forecast coronal mass ejections. If you're wondering how, I'm not going to tell you. You'll just have to watch the videos. But in any case, Earth solidly in the South Pole current sheet, where it will remain for the foreseeable future. And South Pole magnetism is largely in charge here. You can see this large coronal hole right in the Earth-facing zone there. Again, coronal hole wind stream expected from that early on the 20th, 2 days from now. Friday morning. Saturday morning. Okay, I've said each day of the week now. In 2 days, the morning of the 20th, is when NOAA is forecasting the geomagnetic storm. Now, we've brought up 2 images here. And you can see the filaments that we just saw erupt. By the time they were shown up as detecting, they had already erupted. And you can see the sunspot group there. It's just an alpha class sunspot. You can find these on the ISWA, the Integrated Space Weather Analysis page yourself. If you want to look at them further, feel free. It's not going to show you very much at this time. Next, going to the real-time solar wind. And we did see some recent shifts in the phi angle. Current solar wind density, 10.1. Just over 10 protons per cubic centimeter. Solar wind speed, 340 kilometers per second. Pretty much background levels there. And let me just check the life of the stream here before we continue on, and everything looks just fine. The KP index, a measurement of global geomagnetism here, is at 1. No surprise there with those weak solar winds. Next, some geospace magnetosphere movies. Here's what's going on in the magnetosphere, and you can see a little bit of high-density plasma there on the dawn side. You can see on the left pane there the equatorial plane right in this area. A little bit of a result of that denser plasma there, around 10 protons per cubic centimeter. A great example of sort of a middle amount of solar wind density. Here's the pressure. And each of these is 4 hours of data. We show it daily since it can't be viewed in the archives. Shout out to University of Michigan. We'll let that play over again as it refreshed. So we see a pretty extended plasma sphere here, actually. You see the outer Van Allen belts are quite far away here on the bow shock side. And they're thin and organized as we have fairly high levels of electron flux. We'll show you more in-depth data into that momentarily here, after we show you ground magnetic perturbations. So going a little closer to home, here are the changes in Earth's B field, another model of the space weather modeling framework. And if you want to read about that, go to any of the Geospace Magnetosphere movies, scroll to the bottom of the page and click Details. You'll find a link to the space weather modeling framework which explains from where the data is derived. So here is the last hour as it refreshed. And you can see the way the South Pole has left the Antarctic continent and is someplace south of Australia. Down here in the southern Indian Ocean somewhere. And we show the data daily due to the geomagnetic excursion. Thanks to our Twitch followers, by the way. They've got a great mobile app as well. And I think it's the world's leading mobile live streaming platform, as people are using their gaming rigs, something which we will be upgrading to soon so we can bring you even more complexity in our live streams. Twitch.tv/smAsho is where this was streamed. By the way, you can follow us all over other social media. Check out links at smashomash.com. We're on Facebook. Did you see our video about the covidiocy spectrum yesterday? We made a video about this horribly convoluted and terrible looking graph. So perhaps check out that video. And if you're watching on YouTube, don't forget to press like and subscribe over on YouTube. I don't know why I have to say this, but do it anyway. Press like and subscribe. You may get information that you wouldn't even see otherwise just in our thumbnails. We compress lots of information into the videos. So if it's too much, sorry. Thanks to our regular viewers. Here at the Smash News Network, least busted name in news. YouTube.com/smashomash, where most of our content is located. Again, if you're a BitChute subscriber, we're getting several hundred views every day on BitChute and less than 100 every day on YouTube. So do the math there. I'm sure it's just because the content is no good, right? Okay. Have you seen Trainwreck Dumpster Fire, the DNC, Bernie Sanders, Google Insanity Files, and more? Most of those videos are on YouTube, and we've got much more content on YouTube than on BitChute. But in any case, thanks to our BitChute subscribers as well. And let's do a cosmology segment, as we've got 3 interesting stories to cover. So let's do it. Today we're not even going to pick a random number, because it'll be a short cosmology segment. So we're not even going to go to the Neil Gorell Swift Bat X-ray Observatory and look up a random object because, well, perhaps there's nothing random in the universe. So here's an artist's rendition of Oumuamua. And you may be familiar with Oumuamua because people thought it was an alien spacecraft because of the reflectivity and other features of the way it accelerated as it left the solar system. So a new theory is that it's made of nitrogen ice. Yes, nitrogen ice. And if Oumuamua is made of nitrogen ice, that could explain how it accelerated, all because of the good old evaporation, the sublimation of ice, where ice turns directly from a solid to a gas. What you would see happen with dry ice in normal room temperatures is what you would see happening as a result of the solar wind striking these objects, and in any case, it creates jets, yada, yada, yada. Pluto's surface is made of nitrogen ice, or has nitrogen ice on it. And one of the new theories is that perhaps it's because Oumuamua, which is Hawaiian for scout or messenger, by the way, is perhaps made of nitrogen ice. Perhaps not an alien spacecraft after all, folks. Sorry if that disappointed you. And regardless of whether I believe it's an alien spacecraft or not, that's the story. You can find it on phys.org in the Astronomy and Space section. Next, let's talk about baryonic matter. As something's been stinking. Something's been stinking in the realm of cosmology. And one of those things is dark matter and dark energy, as there are issues as to how galaxies hold together and how they accelerate and how they rotate and so on when it comes to cosmology. And it's looking more and more like we're just not able to see all of the matter because it's not illuminated by bright things like the cores of galaxies, quasars, blazars, etc. And just a little consumer tip here. This is the halo. So we've got an image here of the Andromeda Galaxy, and then you've got this halo. And a couple things about galactic halos. One, they're very difficult to see without doing a complicated and expensive study of the area around the galaxies to correlate them with percentages of gas, mostly hydrogen. But here's another thing I would like to just quickly bring up while we have this great image on the screen. So what you're looking at here is the Andromeda Galaxy and how large its halo would be if viewed with the naked eye. Now, yesterday we talked about the size of Jupiter's magnetosphere, but we're not going to talk about the magnetosphere of Andromeda. We're going to talk about Andromeda's polar field. So in the center of the Andromeda Galaxy, there's this spiral, and at some sort of an angle, there's most likely a jet coming out of this galactic core. I'm just going to draw it in like a little tornado here in two directions, assuming that it has a single core main feature. The Andromeda Galaxy may be producing plumes of high-speed protons traveling in outward directions mostly, but also with some channels traveling backwards, and with connected train cars of electrons in between these little clouds. Usually what you see is a pulse. You'll see a pulse of material, and then a pulse of material, and then a pulse of material. And that's just the way plasma propagates through space. And I forecasted over 2 years ago that we would see multi-million light-year length jets coming out of these sort of features. And the next article is about just that. But before we do that, back to this one, baryonic halos. As we're not able to very easily see particles that are doing certain things like accelerating at extremely high speeds. And so this is how we get the argument about that dark mode matter and so on. But the point is, perhaps the universe is not made of any dark matter or dark energy, and everything is a lot simpler than it looks. So again, it's difficult to calculate how much regular old baryonic matter, things like protons and neutrons, are in a galaxy, especially if those things aren't interacting with anything, if they're not illuminated by local photons, for example. So in any case, this article is on phys.org in the Astronomy and Space section, and I'm going to move on. I don't want the cosmology segment or the daily space weather to be too long here. But the next one is more interesting to me. So this is located about 11 billion light years away, when the universe is believed to be only 2 billion years old, which means we're seeing light from an extremely organized set of galaxies. So this is a galaxy cluster. The name eludes me, but what you're looking at is a very, very long string of somewhat connected gas. So the galaxy halos that we were just showing you apparently are a little bit longer which means they're probably also a little bit more massive. And when we're talking about things that are, well, tens of millions of light years in length, hold on, let me get the exact number. So yeah, that's believed to be about 11 billion light years away, as the universe is believed to be about 13 billion years old. But in any case, we see strings coming out of the poloidal fields of these galaxies that are apparently a little bit longer than folks thought. So, and I predicted this over 2 years ago. You can view our conversation with Gareth of See the Pattern, where he didn't listen to me about poloidal fields. I wonder if he's listening now. Probably not. But in any case, I don't really care because I have the correct information and he has a bunch of nonsense about electric stars, something that aren't real. So in any case, these are ultra long filaments here, folks. And I just want to get the length of these because astronomers have long assumed that billions of galaxies are connected by a huge cosmic web of gas flows. The web is difficult to see because it generates almost no light. Until now, only nodes in the cosmic web had been mapped using quasars, because quasar is like a flashlight that you're looking directly down the beam of. You're looking down the poloidal field. These supermassive black holes in the centers of galaxies whose surroundings emit enormous amounts of light, the light is often scattered by the cosmic web, making the web around the quasars visible. Unfortunately, quasars are rare. Moreover, they're located at nodes of the cosmic web. As a result, they provide a limited view. So perhaps that will get some wheels turning into the way galaxies interact with each other. They interact like particle beams with each other. Yes, they inject particles into the other galaxies, folks. It's a thing. I forecasted it years ago. And at least now, here's a mainstream article on phys.org. We're talking about many, many Milky Way galaxies in diameter here. I want to say like 50 Milky Way galaxies in diameter, but I don't want to give you the wrong number. So anyway, there's a very, very distant galactic cluster that we're looking at here, and really lengthy filaments, which are being ejected from, again, the poloidal field. So this is probably a jet right here, and this galaxy is probably oriented with its other jet sort of in this direction. You can see that jet right there, a nice straight line out of that particular area. And this explains why galaxies tend to be at 90-degree angles to each other. But without going further into that, it's another phys.org article. This one is Astronomers Map the Silk of the Cosmic Web. And that's today's cosmology segment. Hope you enjoyed that one, if your brain wasn't completely fried from watching yesterday's. And I've been your host, Dan, a.k.a. smAsho. And don't forget to press like and subscribe if you're viewing the content on YouTube. Share with your friends, your foes, your science noobs, and your science pros. Going back to some more data here from the Smash News Network to look at the electron flux over the past year. And you can see we're at pretty high electron flux levels here, as this Solon.info convenient one-year chart is showing us. Here's a 3-day chart of the measurements by the GOES 16. It's at about 300 kilometers right now, measuring the ionosphere. And we finally dropped out of warning levels here, having seen a little spike. And you can expect to see this crater in about 2 days. On the 20th, the morning of the 20th. And you can see the forecast here by NOAA agrees with what I've just said. No, I didn't look at it beforehand. I understand the physics. Anyway, there's the relativistic electron forecast model. The green squares are the forecast, and the yellow diamonds are the observation. Here's the air column. You're looking at the entire air column here and electrons therein. This is till about 12,000 miles of altitude, and it's through the inner Van Allen belt, but not the outer one. It'll show you GPS errors. And we see a fairly organized electron flux here, no major anomalies. Some slight ones over northern Australia, Greenland, and so on. Some over northern Africa, but it's mostly pretty organized here, folks. It'll get less organized when the coronal hole wind stream strikes. And again, here's what you're looking at in that image. It's this satellite down to the ground level, about 12,500 miles of altitude, and through the inner Van Allen belt. Here's another diagram closer up to the atmosphere, and we're showing you this because we're going to show you a visualization of this portion of the atmosphere known as the ionosphere, where the GOES 16 is making those measurements. So here is that. It's courtesy of Australian Government Bureau of Meteorology. And keep in mind the resolution here is only 1 megahertz. Don't be megahertz by the fact that you're not forecasting earthquakes, because people have been trying to forecast earthquakes for a long time. And we don't discourage people from forecasting earthquakes, folks. We encourage people to forecast earthquakes. We just prefer that they don't lie about it. That's all. And we see some major charge-ups here over South America. That's actually a little anomalous there, folks. I'm going to let it play through a second time. You see these large charge-ups here just west of the South Atlantic anomaly. You're going to see this reach at least 13 megahertz. Right in this area. So that was kind of a sudden charge there. Not particularly normal, but a little bit south of the South Atlantic anomaly. So, and by the way, there's actually 2 really weak spots in the magnetosphere right now. One is over here somewhere, and one is down here somewhere. As we've got, really, the South Atlantic anomaly has split into 2, the South Atlantic and the South African anomaly, something that we would expect to see as the magnetic excursion continues. Anyway, here's the latest image from 9:30 Universal Time. And again, that was the F ionosphere layer about here, around 300 kilometers of altitude. Next, some meteorological stuff. First, me checking the life of the stream, and then vanishing, as if I had robbed a bank. Don't worry, folks. I didn't rob a bank. Here are the jet streams of the eastern world. And we see the backward flow over the Indian Ocean breaking up a bit here. Not quite as defined as it was. Doubled up jet streams in the north, and some pretty serious kinks in the south as well, but looking a little bit less anomalous there. Here is the jet stream scenario for the western world. And much more anomalous over here. We've got the jet stream blowing straight up backwards over part of South America right there. A double S-bend over only 1,500 miles or so. And we've got a due north jet stream right here. So some anomalous stuff, some anomalous things going on there, folks. Let's take a look at the surface winds real quick. And we see a huge bend in surface winds here, right at Bermuda. So that's an interesting little kink there in surface winds, and that'll be creating some high seas and some low seas close to those border areas there. And we see doubled up and tripled up jet streams here over the northern hemisphere. Quite chaotic jet stream flows on the western side of the planet. Here's some more meteorology stuff. How about pressure cells? I show them daily. It's windy.com. And let's show you the GFS and the Euro forecast for pressure. Here's where things are today. And here's where things are expected to be tomorrow. And there's the Euro forecast. And there's the Icon forecast. Again, there's the GFS, and there is the Euro forecast for pressure. It's all on windy.com. They've got a great mobile app. We're not paid to say that yet. Drop us a line, windy.com. And we see the lines straightening, folks. Check it out. It's almost equinox time. We see the lines straightening out. We will be streaming live for the equinox, by the way. We'll be doing a YouTube exclusive live stream if you're watching any place besides there. Watch our daily space weather on the day of the equinox, because we'll be streaming at the exact moment of the equinox to be the first channel to wish you a happy spring or perhaps a happy autumn to our south of the equator viewers. Anyway, we're on blitzortung.org and we see some active lightning. It's an active lightning map. And we hope you get your lightningmaps.org servers back soon. Blitzortung, thank you for your fantastic service. Blitzortung.org. Shout out, drop us a line, blitzortung.org. We'll be happy to feature you on the channel as well. By the way, we've got an upcoming collabo with Rag Reynolds. If you haven't seen Rag Reynolds, check him out. And we see some lightning near Knoxville, as well as south of the Florida Panhandle. If you're in Tallahassee or Mobile, go outside and take a look. You may see some interesting phenomenon over the top of those thunderheads known as sprites, elves, etc. Next, looking at the cloud layer. And we show the cloud layer all the time using the NASA GOES shortwave radiation map, as we prefer to show our channel viewers things that would otherwise be hidden. So we've got this large rotating low in control of things, but it's surrounded by dry air, folks. So you see this low right here, it's rotating counterclockwise. Well, it's weaker than it may look because of all of this dry, massive air. Dry, massive air slows these systems down, and that's what's going on now. Although that low pressure is causing this moisture to take its time in moving to the northeast. So that's what the water vapor map tells me. And if you're ever unimpressed by the Doppler radar map, just check out the water vapor. And we're actually going to zoom in on Missouri for once. Going to zoom in on the Missouri-Arkansas border here, just to show you some weather pornography. It's a bonus feature. So we got a great view of this counterclockwise rotating low. And there should be some interesting cloud formations in that area, to say the least. And leave us a comment with a link to your Instagram page or whatever if you've got some material you'd like us to show on the channel. Great view of that. There's the cloud layer, and there's the water vapor. A bunch of dry air mixed in the middle there, which will create some odd wind patterns and so on. And if you're flying a plane across there, expect some pressure gradients, to say the least. Again, there's the U.S. Doppler, the entire eastern portion of the country, seeing some rain over the previous 6 hours and the past 24 for sure. Next, I'd like to thank our patrons, the true source of funding for the content. Please consider becoming a patron at patreon.com/smAsho. It gives us some idea of what our budget is, which is just this side of nothing, due to our pathetic views and subscriber count on YouTube. So please consider becoming a patron. Increase the probability that these videos will continue to exist and be publicly visible by becoming a patron at patreon.com/smAsho, or perhaps check out our links or whatever. Support the channel in whatever way you see fit. And did I fail to do the Patreon credit crawl? I failed to do the Patreon credit crawl, didn't I? All right. Again, thanks, patrons. That's why I put your name in lights. If you want your name in lights, patreon.com/smAsho. You get all kinds of other features as well. Speaking of features, here are bonus features. Here's what the colorized magnetogram looked like when I did show prep. And here's what the intensitygram looked like when I did show prep. Sunspot 2810 is degrading. And here's what it looks like now. It's remained stable for the past half hour. There's the refresh. There's the colorized magnetogram. And it's looking pretty weak. It's still alpha class. Nothing to write home about there. Here's a close-up of the northern hemisphere in 171 angstroms. Also an active region over there in the northwest. Again, look for a second video coming out today. We'll probably do a second video about the coronal mass ejection that's unfolding as we speak. First, a 94 angstroms close-up of sunspot 2810. There is some likelihood of solar flares. And again, a coronal mass ejection. We'll have to cover it later. If I had to guess, which I don't, I'd say it'll miss Earth to the southeast due to its location and properties during ejection. And that's the last view we'll show today. Thanks again for tuning into the Daily Space Weather. Please visit our links, support the channel, and may that solar wind be at your back.